Hello and welcome to the next video where we are talking about collections, data structures and overall how to store data within Java. As I've said, this is a video in the series, so if this is the first video that you're seeing, then please go ahead to the playlist that is in the description and catch up on everything that we have been talking up to this point. So in the last video, what we talked about was how to sort collections and how to compare them between each other. But now let's talk about a more advanced mechanism that is way useful not only for sorting but also in the usage of the collections that we will be talking next. The topics of this video will be equals and hashcode methods and HashSet and how to use it and what are the benefits and cons of using a HashSet. With that being said, let's just start out with equals and hashcode. So potentially, you have already been using equals, especially when talking about strings, right? Because as you may remember, when we are talking about strings, then if we want to compare one string to another, for example, John, then we can't really use equals sign to compare it to anything else. Here I've got a situation because those are actually string objects, right? And whenever we are talking about comparing objects, we want to use a dedicated method to compare them, because at this point in time, we know by looking at this that those are not really equal, but how to tell it to Java that, hey, those are not equal, right? Is it by length? Is it by the characters that are there, or any sort of another way, right? So this is very, very important, right? For objects, we can't really use the equals sign. We can use it for primitives, but not for objects. So in this case, if I wanted to compare the two of those, I would need to use the equals method. And then I can just print out whether John equals Joe, and of course it's false. So equals is just a method that gives me information whether one object is equal to the other one. But of course I've talked about equals and hashcode methods, right? And what's the relation between those two, how to create your own equals method and how to actually work with those. So let's just dive right into it with an example. Let's go ahead, create a user class, if IntelliJ allows me to. And let's create a user and let our user have a name. And let's say that there will also be age for the sake of simplicity. Let's generate a constructor. Let's also generate getter and setter for both fields. And then let's discuss a little bit about equals and hashcode. So where do we get those? As you may or may not remember, every class that we have in Java actually has the equals and hashcode method already. This is because we are getting those methods from the object class, which every single class in Java inherits from. So now that we've got our user, let's try and compare two users and see whether the same two users will be the same. So let's just create user and import it, of course, or rather not. User equals new user, and let's say this is going to be a John with age of 25. Let's copy over this one, but right now it's going to be user 1. So as we can see, those two users are virtually the same, right? We've got the same fields, same values. So if I were to print out whether user is equal to user 1, we're expecting to get true. So let's see if that's the case. It really isn't, it's false. So in the original implementation that we are using from the object class, we can only get true when we are using equals if we are really using the same exact field, because right now what we are comparing is the reference, meaning the space in the memory of Java Virtual Machine between those two. So if they are not actually the same object, so for example user equal to user itself, then we will always get false, but we will only get true if we compare the same objects. So this is something that we need to fix, but about this in just a second. When I'm talking about user, I can also get hashcode of it. What is a hashcode? Essentially, this is a way of shortening the object itself to a string of numbers and random characters, right? Because this is actually a code that we can use to really identify this particular object. So the way it works is that we are just using a hashing function underneath, and what it happens is that we just get a code that we can use to identify this specific object. So let's use user hashcode, and let's also print out user1 hashcode, and let's see whether they are different. And yes, of course they are different, because right now I'm using implementation from the default method. But actually there is a sort of a construct. So whenever we're implementing equals, we also want to implement hashcode. The context of it will become a little bit clearer when I move on into the HashSet, so actually a collection that is using this particular mechanism. So the way it works is that whenever I'm implementing equals and for two objects it returns the same value, for if the two objects are equal, then we need to get the same value of the hashcode. And if the objects are not equal, meaning that equals method returns false, then we should be getting back information and that the hashcodes are also different. So if we go into our user class and let's see how to implement the equals and hashcode method. The easiest way to do it is to just use generator that is within IntelliJ, use Alt Insert on your keyboard, select equals and hashcode, and then this is what you will get. So let's talk a little bit what is happening here. So first of all, we've got this equals method, and let's see how it looks. If this equals O, so the object in the beginning, then return true, meaning that we are comparing the same object. And here we can use the equals because it's using the reference in itself. If O equals null or get class is different to the class of the object that we are comparing, then we return false. Then we are casting the object to the user, meaning that we are then transforming the object that we get here to the user itself, and then we compare the fields, meaning that we check whether the age is equal, and then we use equals method of the string name. And if we are talking about hashcode, then we are using the name and age values to the hashing method that actually tells us how to make it into this random string that we see over here. And if the fields are equal, then of course we are always going to get the same value. But if we go into implementation of the hash method, then we can see that it's just pretty simple that we are getting this kind of number in it. So now let's see what has changed, first of all, with hashcodes after implementing this. First of all, hashcode is the same for those two objects. And then if I go ahead and print out whether user is equal to user1, then of course I will get true. So now we've got equals in hashcode pretty much out of the way, right? We know how it works, we know how to use it. And why are we actually bothering to use it so much, right? Because I can just see whether something is not equal or not. And what are the mechanisms, like what are the benefits of even using this? So to answer your question is, there are collections that are making use of this mechanism to ensure that there are, for example, no repetitions underneath, and they are very, very fast to use. The first one that we're going to be talking about within this video is HashSet. So how to create a HashSet? Very similarly to what we've had in the past with the array list. So first of all, let me just delete this, and we're going to be using users. So of course, if we have users, we want to make sure that we only have users which are not repeating themselves, right? We cannot have two users which are with the same data, because then we could have a problem. Imagine that there is a problem on the programming site when you are trying to log in into your bank account, and it turns out that you log in into another person's bank account, right? There will be a ton of problems with it. So this is actually where we want to make sure that there are no repetitions in the way that we store our data. So let's create a HashSet that is going to be using the user class as the objects that we will be storing. Let's call it users HashSet, and of course equals new HashSet. So essentially the same. So the key differences that we need to consider. First of all, HashSet does not use indices, meaning that we cannot use any sort of number to get our users. Second of all, if we use HashSet, the data will not be ordered. Very, very important. And of course, there are no repetitions. How does it work? And let's talk a little bit about how it looks like underneath in the HashSet. So the way it works is that whenever you try to add up an object to the HashSet, of course, we can only use objects, no primitives here as well. Collections, only objects. So whenever there is a HashSet, so the way it works is that it takes in an object and assigns it into a bucket, which is using the hash code as, let's say, identification number of the specific bucket. So if there is nothing in the bucket now, then it will just insert the object. But if there is a situation that, for example, the end user, we try to add up an object with the same hash code, then it checks whether there is something already in the bucket, and if there is, then it uses equals method to try and see whether those two objects are the same. Because of course, while hash code should be different for every object, which is not the same, then of course, there are some cases, very rare but not with big enough data sets, where hash codes for two different objects of the same class is the same. It's called hashcode collision. Something that we want to avoid, because otherwise it's getting really, really inefficient in terms of retrieving data. With that being said, let's look at how to actually use HashSet. So let's say I want to have just a set of my users. I don't want for them to repeat, right? So for that, I have created a HashSet, and let's see how it works. I can go ahead and for my user HashSet, use method called add. And there I can just add up a user. And let's prove that only the users which are unique will be put into it. So afterwards, after adding two users, let's just print out the size of our HashSet to check how it works. So now let's run the program. And yeah, and the size is 1. We only get a single user from it. Very, very important. If I were to change something, for example, I've changed John with an H to John without it, then of course I will get 2. So it works nicely. So we know how to add objects, we know how to print out the size, we know that they are of course distinct. So let's talk a little bit about going through all the elements that are within a set. So of course we cannot use indices, right? If I go ahead and use the HashSet, I want to get any object, I don't get the method for it, right? And as I've said, we are using only the hash codes within, and we can't really predict hash codes, right? It's not very friendly to use. So in order to traverse a set, for example, I want to print out all the users that I have saved, then what I need to do is use an enhanced for. So the way to use it is this. I use for, as I would usually do, and then I use the class that I want to use. In this case, it's going to be user. I'm going to give it a temporary name. And then after a colon, let's call it temp user so that there's no conflict. After a colon, I put in the collection that I want to use. And then for all the users within this user hash set, I can print out, for example, let's say temp user.get name. So this way of writing down the code means for every user that I will call temp user within user hash set, please print out name of the user. So let's delete this print so that it doesn't pop up, and then we can see the way it works, right? So very, very important. And even here, we can see that even though I have added user1 with an H, then another user without the H, then I still get them mixed up. So very, very important. Do not ever use HashSet whenever we are talking about making a collection that we want to keep any sort of order within, because we cannot guarantee any order. As you can see, even with 2 examples, they are switched with the way that it works. So very, very important to remember. And then last but not least, very useful for HashSet, we can always delete elements from it. But if we want to delete it, I can either use clear, which deletes everything, or I can just go ahead and point out exactly what I want to delete, but then I need to use a reference to the object. For example, in this case, user. So I know that I have added user, I have added user 1, and then after I remove it, then of course the size will change from 2 to 1. So for the last exercise, let's just try to delete user and see the size of it. And yeah, I get 1. So to sum it up, HashSet is very, very important to use, but still the more important part is equals and hashcode methods to make sure that it works well, that actually we can use HashSet and the mechanisms underneath it. And then again, whenever we're talking about HashSet, please do remember, there is no ordering, we cannot use any indices, all the elements need to be unique. And of course, HashSet on its own, it's not very, very useful, it's not very commonly used. But when we're going to be talking about the next collection, namely HashMap, in our next video, then you will see the power of the HashSet that it gives us and the fact that we can use this mechanism of unique elements within it to really build out some nice applications and nice code. So thank you very much for watching this video. If you want to do any exercises, if you want to remember everything by practice, then please go ahead into the one of the another links in the description where you can find all the materials in written form and everything that I have said here in writing so that you can repeat and not have to listen to this lengthy video. But then again, if you want to also join the group where we are going through those exercises together, if you have any questions or just want to pop up, then please also go ahead and join our group at school.com. So thank you very much. See you in the next video when we are going to be talking a bit about hash maps. See you there.